Okay, now it's time to read the architecture of the ISDN. Okay, we have here the customer's equipment and we have here the carrier's equipment. Now, the basic idea of the having the ISDN is a digital pipe which is going all around here. Let me take a pen if I have. No, let me pause it. Okay, here we go. The basic idea is to have a digital bit pipe. The digital bit pipe, goes from the customer's equipment to the carrier equipment. Now, in a customer equipment, you could have a telephone, you could have the computer, you could have the alarm, or you could have any more devices which produces some digital data. And you have a digital bit pipe, which the bits pass in the both direction, from the carrier customer equipment to the carrier, from the carrier to the customer. Okay, now we may have a lot of channels in this bit pipe, and this can be done by the time division multiplexing, because I need, for example, I have three devices here this time, so I need to multiplex my digital pipe. So maybe I will use a TDM. Okay, now there may be two such architectures. One is for the home use, okay, or one may be for the business use. For the home use, you maybe have low bandwidth standard and higher bandwidth standard for the business use. That may support multiple channels. That will be like a home use, but you may have the more demand in the business, so you need something different. In this home use configuration, what we have basically is we have the network terminating device NT1, which is here, that is being placed on the customer's premises. So this NT1 is the part of the customer's office. So that's up to this place, up to this point, this is all customer's premises. You getting me? So we place an NT1 network terminating device on the customer's premises, and this guy is connected to the ISDN exchange. Okay, which happens to be at the carrier's office. So whosoever the carrier, for example BSNL or whosoever your carrier is, that ISDN exchange gonna be there. So that's gonna be far away. So therefore we need to have a twisted pairs. Using the same twisted pairs which I was talking about before, that we have already twisted pairs here. So this is whole bunch of twisted pairs here, because this is already been placed. So I'm using these twisted pairs to connect my NT1 network terminating device with my exchange. So NT1 box definitely gonna have some connectors on it, into which some passive bus cables can be inserted. So up to 8 ISDN telephones, terminals, alarms, and other devices can be connected. So you can have an 8 devices which can be connected with the NT1, because NT1 is not a it's for home use. So we do not reckon that you may have the huge need. Then you need something else. You need maybe the private branch exchange here, which I will be telling very shortly. So from the customer's point, the boundary is the NT1, okay, which is all digital here, and here actually is an analog twisted pair, but we have the ISDN protocol which converted into the all digital bit, which makes it like a digital bit pipe, and we have the ISDN exchange which is at the carrier's office. So then it will go to the carrier's internal network. Okay, but if you have huge demand, you have you need a lot of equipments to be added on, so NT1 is not sufficient. So you need a private branch exchange here, which I will pause my video and draw this diagram for you. Okay, now here we got the new diagram. Let me also get the hand tool maybe. Okay, now this is a little different from the business. This is the the home user, or this may be some business user, because this bit pipe for the home user can't handle that much of traffic which is being here. So therefore we need a box, something to handle this load. So I need a real macho man here, So it is a macho man, is basically the NT2, what do you call the NT2 ISDN private branch exchange, PBX. This is going to be my private branch exchange. And I can have a lot more things here, the computers, the terminals, and I got here the this is the basically I forgot the writing the names actually. Okay, you can say this is the TE1 ISDN terminal. Okay, this is gonna be the ISDN telephone. This is here we may have non-ISDN terminals. Those guys will be here. Okay, and then this is the LAN gateway. This is the LAN gateway. Okay, and we need for non-ISDN we need something here. We'll be talking about these things in a short while, but the main thing about this diagram, and which is being home user and the business user, is that we need what's called as this the private exchange. It's not a big, it's not that much different from this ISDN exchange. Okay, it is a smaller version of this big daddy. This is a big daddy and this is a small son, but for this it's big daddy. Okay, because what happens is it can handle a lot of calls at the same time, but this is a mammoth. This is a big daddy which can handle have a lot of things, because I'm talking of one business user. There may be thousands of business users which are connecting to this ISDN. So don't go for this size and this size. It seems smaller. It's actually huge than this. Okay, this is small son of this big daddy. Now CCITT has defined some reference points. CCITT means actually Consultative Committee, that is CC, Consultative Committee for International Telegraphy and Telephony. CCITT. So what is CC? Consultative Committee for International Telephony, in fact telegraphy and telephony. That is CCID. It has defined some reference points, as you will see. I'll discuss them, like S, like T, like U, like R. You're seeing a lot of things there, so we can discuss them. What are basically these guys? Okay, and reference point, what I'm talking about. Before that, we may also discuss a little bit about the terminal equipments. Like we have terminal equipments like TE1. These are TE1 equipments. Okay, and there may be TE2 equipments also. Then there is a terminal adapter. We have terminal adapter, and this guy is TA, is a terminal adapter, is being used for the non-ISDN equipments, because these are the non-ISDN equipments. You getting me? Okay, does it make sense or not? Good. Because if you have non-ISDN equipments, you need a terminal adapter. Now interface between that is gonna be R. For TE1, okay, terminal equipment 1, these are, because these are TE1, this is TE1. For them to the private exchange, we need an interface reference point. It's called the S. Okay, and for between the NT1 and then we need a T and U and all that. But before we discuss something like TE1, what is the terminal equipment 1? This is actually called the terminal equipment type 1. So this is a specialized ISDN terminals, these guys. So like telephone instruments, fax, or we may have something like we may have something like what else? We may have like burglar alarm. We may have alarms. These are all TE1. So they need to be connected with the ISDN network if exchange using the NT1. Okay, we need an NT1 device to connect them basically, if we have this. But if it is a, I'm gonna say if it is a home user, but if it is an business use, then it's an NT2. We need a private exchange to connect them. And they have the bus interface. They have called the S bus interface. They have the S bus interface to connect here. Okay. Now TE2 are like I said, TE1. This is a TE1, but on this side we may have TE2. That's the non-ISDN compatible equipments. We call them a type 2. Like we have analog phones, because I'm talking about these guys can handle on the digital telephones, digital computers, or etc etc. But you may have some analog telephones, they are non-ISDN, so you can connect them with a terminal adapter with an R interface. You getting me? That does make sense or not? You may have some fax machine and other guys also, so they need to be connected like analog stuff. Then you connect it with the TA, terminal adapter. So what is the TA doing is basically it is a intermediate device for non-ISDN interface devices. Okay, so therefore these guys, the terminal adapter connects all these analog non-ISDN devices with the NT2 or private branch exchange. Now this guy has a special physical layer interface. uh, what we might have read about the serial interfaces or analog interfaces. Okay, in this we have read actually already read about RS232C, or like about the modems. We need modems, maybe we need modem V.24 or V.25, and EIA TIA 232C. Like these interfaces are here, like EIA slash TIA 232C, or which was basically called as RS232C. Previously we read about this RS232C and EIA TIA 232C. Or we may have the modems like V.24 and V.25. Now NT1 here is the network terminating device, okay, which is at the customer's premise. It provides all the things like monitoring, power feeding, error statistics, and proper timing. It also depends. We call them NT1s, but according to some locations, we have different names of NT1. Like some people call it CPE, maybe in North America, and so on. They have then the local loop on the right side. Is it? Local loops on the right side. That's going to be the twisted pair. And if we have the NT2, this guy, this is something which can handle a lot of stuff. So this gonna provide you the switching, multiplexing, and a lot of things, because you may have some LAN servers also here. So simply this is a private branch exchange. Now there are a lot of reference points being CCI double T. I told you this is that I put up some the reference point, like we have the R reference point, that's called rate. R is called rate. So this R is for the interface for non-ISDN devices. Okay, so there need to be a reference point with non-ISDN equipment and TA, terminal adapter. So what this reference point can be? This is going to be your RS232C, V or X series. Okay, or this may be just simply you have your telephone. If you have your analog telephones, they have the two pins. This R can be well that two pins, two pin socket. Sometimes we have the landline phones. Okay, this R is can be that, because your telephone which you use it to talk in a BSNL telephone, landline telephone, what you call, that is having two pins. Those two pins is itself an interface. Okay, that's very simple interface for the analog telephone. This R can be that two pin interface. You getting me? Okay, now S, so R is for the rate, S is for the system. So this is going to be the user terminal and NT2. NT2 device, NT2 private branch exchange, or whatever you call it, and then the interface between these guys and NT terminal equipment 1, type 1 devices. So what is basically this S interface? Because you need some plugs which will plug in from here to here and here to here. So is you getting me? So this is going to be a 4-wire balanced bus to which up to 8 ISDN terminals can be connected. So therefore the S terminal is something which is the 4-wire balanced bus, and you can connect 8 ISDN terminal because they need to be ISDN. If they are non-ISDN, then you need an R interface and also the terminal adapter, which will basically convert these guys, analog to the digital and so on. So what could be the here, if you use intuitively your brain, because the digital device like a laptop, you want to connect into the NT2. So the better thing you can have is, because you have the LAN interfaces, Ethernet interfaces already there, so the interface, the S interface, can easily be RJ45, which we have developed already. Is it okay? In which we have the 4PS and all that. RJ45 can be the 8-pin RJ45. No, we have 8 pins, 4PS, oranges, and etc. White, orange, and all that. We have developed that in the lab, and this S interface can be easily the RJ45 interface, because this is the already digital device, and this is going to be the digital also handling exchange. So therefore you need an interface that's going to be your Ethernet RJ45 interface, 8 pin. Now if it's a T, T is common to the both guys here and here. It's a T. Okay. So the T is the interface between NT1 and NT2. If it's an NT1 device and NT2 network terminal adapter 1, network terminal adapter 2, so you need an interface between the two guys, you need a T. Okay. Then there's going to be U, the U. Now you can understand what's U. So it's going to be the NT1 device and the ISDN exchange. So what this U can be? Can you tell me? Can you tell me what the U can be? So this can be simply a copper wire, a copper pair of the access network. You have a copper pair, just plug it in together, because this is all here the twisted pairs. So you can plug in these copper wires to connect to each other. And this pair can be used for full duplex transmission. We have everywhere it's a full duplex transmission from this way and that way also. Okay, so what's left out? Is there anything left out in it? I don't think so. I am chucking myself something in the shop. I think that's it. Now that's about the architecture of the ISDN. Okay, thanks for watching.